In the previous section, we looked at how we can go through and start evaluating functions and what a function looks like. In this video, we're going to take a look at how we can continue to evaluate functions, but this time not just substituting numeric values, but algebraic expressions. And so what we have is we have this function, we're defining it as g, all right? So the name of this function is g, and g of x is equal to 4x minus x squared. And we want to try to simplify and evaluate when x is equal to negative x and x is equal to x plus 2 and simplify it if necessary. And so just like we did before, what we're going to do is we're going to substitute negative x back in anywhere we see an x. So this is going to be g at negative x is going to be equal to 4 times negative x minus negative x squared. And so the first expression, or the first of the two terms, we can think of that as negative 4x, since we have a negative 1 times 4, and that just becomes negative 4x. This one, if we think of this as negative 1 and we square it, we can think of this as just regular x squared. And the reason that is because we can think of this as negative 1x times negative 1x, right? And remember, anytime that we try to square something, we just multiply it by itself. This minus sign just comes down in the middle there. And so we know that negative 1 times negative 1 is a positive 1, and x times x is x squared, otherwise known as x squared. And remember that the negative sign just comes down. So this is one way to write g at negative x. Another way to think of g at negative x is if we were to factor out the negative sign, we could just have a negative 1 out front, and we could write that as x plus, or 4x, excuse me, plus x squared. That's just another way to algebraically think of it. Or a third way is to get rid of the 1, since anytime we multiply anything by 1, it's an identity. And we could think of this as negative 4x plus x squared. All right, so just different ways to be able to think of how this might look like. Now this time we have a binomial that we're substituting x plus 2, and we're going to substitute it in for x in both places. So this now becomes 4 quantity x plus 2 minus the quantity of x plus 2 squared. And to simplify this, we're going to have to do some polynomial multiplication. So we certainly know that we can distribute the 4 to both of those terms in the first set to get 4x plus 8. When we square something, we write the same thing next to itself. And this is extremely important with binomials. A common mistake that students make is that they think that x plus 2 squared, that they can distribute the square to both terms. That is not true, okay? So what we have to do is we have to write it next to itself. And then if we go through and FOIL this, so we're going to do first, outer, inner, last, we have a minus sign. So x times x is going to be x squared for the first terms. X times 2 is going to be a 2x. 2 times x is another 2x. And then finally, 2 times 2 is going to give us 4. Now what we can do is we can go ahead and we can distribute. So we're going to distribute the negative to all 4 of the terms. And of course, we could collect like terms as well, and that's fine. So this is going to be 4x plus 8 minus x squared minus 2x minus 2x minus 4. And then finally, we can combine the like terms. The only like terms are going to be the x terms. So we have 4 minus 2 minus 2, and those all just cancel out because we get 4 minus 4. And then the other terms are the constants. So we have 8 minus 4, and that's going to be a positive 4. So one of two ways that we could write this answer. We could write it as 4 minus x squared, or another way we could write that is x squared plus 4. All right, so either way we write it, they're both algebraically correct. So that's how we can go through and simplify these algebraic expressions if substituted into functions. A couple more examples. So let's define the function h. So now we're saying that h is equal to x squared plus 1. And we're going to do the same thing. We're going to substitute 3, negative x, and x plus 1 back in for x squared. And one of the things that I might suggest is that as you guys are going through this, if you've seen a couple examples, it might be helpful for you to pause the video to try to work through these on your own and then to watch the video after you're done to see if you got the right answer. So if you want to pause it at this point, maybe work through these three and then see if it works out for you. When you unpause it, that might be helpful. So what I'm going to do is I'm going to substitute 3 back in for x. And so this becomes the square root of 3 squared minus 1, or the square root of 9 minus 1, or the square root of 8. Another way to write that, if we think about this, remember that 8 is 4 times 2. And so another way to write this is to say, okay, well, if I have the square root of 4 times the square root of 2, we know that the square root of 4 is 2. So there are 2 different ways to write this. The most simplified way is 2 roots of 2. All right, so anytime we have a number that contains a perfect square as one of the factors, we might want to factor it. Okay, so something like maybe square root of 72, which we know isn't a perfect square, but we know that that's 36 times 2 is 72, or we can write that as 6 roots of 2. All right, so that's just the secondary example. I know this has nothing to do with the problem that we just did, except for showing you how to algebraically simplify numbers that might contain perfect squares as one of their factors under a square root. Similar to one we looked at before, we have a negative x, and we're going to substitute that back in for x squared. And so h at negative x is going to be minus x squared minus 1. And whenever we square a negative, it becomes a positive. So this is just going to be x squared minus 1. I want you to notice that this is not equal to the square root of x squared minus the square root of 1. Okay, or you can't just write that as x minus 1. That is not correct. It only works with multiplication. Okay, so if I have a squared minus b squared under a square root, that is not the same thing as the square root of a squared minus the square root of b squared. But if I have a squared times b squared, then that is valid to break that up as the square root of a squared times the square root of b squared. All right, so be careful with your algebra rules. Okay, one of the most common mistakes I see students make is that they don't follow these rules of algebra, and it might just be that they don't remember them from other classes, etc. So it might be helpful for you to write a list of these down as you're going through. Finally, we have h at x plus 1, and so that would be the square root of x plus 1 squared minus 1. Remember, when you square something, you write it next to itself. So that's going to be x plus 1, x plus 1 minus 1. And then we can go ahead and FOIL. So that's going to be first, x squared times x squared. Outer is going to be 1x. Inner is going to be another 1x. Last terms, 1 times 1 is 1. And then we drop down the negative 1 from before. If we combine like terms, this now becomes x squared. We have 1x and 1x, which is 2x. And then we have 1 minus 1. Those are opposites. This is as simple as we can make it. If we wanted to, we could factor in x, but keep it under the radical. So another way of writing this is x times x plus 2 as a greatest common factor. All right, so I don't know if there's any benefit to writing it in this form, but certainly it is one of the ways that we could write it. So that's how we can go through and substitute into our functions and to be able to simplify algebraic sorts of expressions, which is going to be important a little bit later when we start taking a look at things like a difference quotient and those sorts of ideas.